Mr. B here. During a chemical reaction, the consumption of the reactants and the formation of the products will follow some balanced chemical equation. However, what if it's unclear whether or not the amounts of reactants on hand will actually match the balanced equation? In other words, might there be too much of one reactant or too little of another? This concept is known as a limiting reagent. A limiting reagent will be completely consumed during a chemical reaction and therefore dictate the amount of products being formed. In this video, I will explain how to use a balanced chemical equation to determine the limiting reagent. Consider the following practice problem. How many grams of precipitate are formed when 30 grams of ammonium phosphate reacts with 40 grams of ferrous nitrate? The first step in solving this practice problem is to write a proper balanced equation where ammonium phosphate reacts with ferrous nitrate to produce ammonium nitrate and ferrous phosphate. To balance the equation, simply place a 2 in front of the ammonium phosphate, a 3 in front of the ferrous nitrate, a 6 in front of the ammonium nitrate, and a 1 in front of the ferrous phosphate. After writing the balanced equation, extract the molar ratio, where the molar ratio will be 2 to 3 to 6 to 1. This ratio may now be used to create a fraction that will relate both the reactants and the reactants to the products. From the practice problem, we are given 30 grams of the ammonium phosphate and 40 grams of the ferrous nitrate. At this point, it's possible to determine which reactant is limiting and which reactant is in excess. However, in order to do this, we first must calculate the moles of each reactant. 30 grams divided by the molar mass of ammonium phosphate, which is 149 grams per mole, will yield 0.2 moles of the compound. 40 grams divided by 180 grams per mole, which is the mass of ferrous nitrate, will give 0.22 mole of the compound. Now the task is to determine which reactant is actually limiting and which reactant is in excess. To do so, just assume that one of the reactants is not given. In this case, I've chosen to assume that the ferrous nitrate is not given. In doing so, I'm assuming that this value, the 0.22, is unknown. Now simply multiply the moles of the ammonium phosphate by the fraction created from the molar ratio, where the coefficient associated with the unknown, which I'm saying at this point is the ferrous nitrate, is 3, and the coefficient associated with the given, which in this case will be the ammonium phosphate, is 2. So my fraction will be unknown coefficient over the known coefficient. This will give me a fraction of 3/2. Multiplying 0.2 by the fraction 3/2 will yield an answer of 0.3 mole. Okay, what does that mean? Okay, it simply means that if 0.2 mole of the ammonium phosphate is available, I actually need 0.3 mole of the ferrous nitrate to completely consume this reactant. However, from a previous calculation, I know 40 grams, which was given, divided by 180 grams per mole, I only have 0.22 mole of the ferrous nitrate. This means that the ferrous nitrate is limiting because I need 0.3 mole based on the amount of ammonium phosphate. But I only have on hand 0.22 mole. So, in this case, the ammonium phosphate is in excess and the ferrous nitrate is limited. Now that I know which reactant is limiting, I can determine the amounts of products formed. The question is asking for the mass of the precipitate. I know that all nitrate compounds are soluble. Precipitate means that the compound will fall out of solution and collect on the bottom of the container. Most phosphates are insoluble. Therefore, I know that when ferrous phosphate forms, it will immediately settle to the bottom of the test tube. The ferrous phosphate will be the precipitate. To determine the mass of precipitate, simply use the moles of the limiting reagent, which in this case the limiting reagent was ferrous nitrate. The relationship between ferrous nitrate and ferrous phosphate is a 3-to-1 ratio. In this case, I'm assuming that the amount of ferrous phosphate is unknown. Therefore, the fraction created will be 1/3. Now simply multiply the fraction, 1/3, times the amount of limiting reagent, which will be 0.22 mole. 0.22 times 1/3 equals 0.073 mole. Therefore, 0.073 mole of the precipitate will form. To find the actual mass of the precipitate, simply rearrange the mole calculation as follows, where equal to the moles of the compound times the molar mass of the compound. The molar mass of ferrous phosphate is 358 grams per mole. So multiplying 0.073 times 358 grams per mole will yield a final answer of 26.13 grams of precipitate.